Hey, let's take a quick time out for some great news. Open enrollment is here. DigitalWorks Academy is offering a series of courses on model-based systems engineering. First up, an introduction to MBSE. This short course is designed for executives, managers, and senior leaders who want to know more about model-based systems engineering. The course explains what MBSE is, why it matters, and how it can improve the scope of projects from cost to schedule to quality. You will be more than ready to support your organization when it inevitably moves to MBSE. Again, enrollment is open right now. To make sure you have a seat, scan the QR code on your screen or go to the link at our website, digitalworks.org. To make sure there's a spot for you, register now. Enrollment is open. Hello, everybody. I'm Steve Johnson. Welcome to DigitalWorks TV. We have a guest today, Dr. B. I want to call you that so badly, but Dr. Patrick Buckley.
We can go with Dr. B.
Who, you're a systems engineer now, but your degree is actually in atmospheric chemistry.
Correct.
So, and I'm sure that's there's probably a long story with that. And maybe, okay, well, let's just talk about you're a systems engineer now. How did you get from atmospheric chemistry to systems engineering?
Yeah, and try to give the brief version, right? Because there is a very long version. So I went to undergrad at University of Missouri, got my degree in atmospheric science, meteorological forecasting, wrote a lot of forecast models, and did a lot of research on convective snowfall, thunder snow. Have you ever seen that video of Jim Cantori going nuts?
There has actually been thunder snow here.
That's right. So. Yeah. So did a lot of research there, and then when grad school kind of became part of the equation, I had two options. I could either go to University of North Dakota and kind of continue my sort of winter weather research, and at that point I had pretty much had it with cold weather and that sort of thing. So I
you could have gone to Miami and been part of the
I could have gone to Miami
Hurricane Prediction Center.
But then the other option was to come here
Yeah.
and basically jump head first into something that I'd never done before, which
And
was atmospheric chemistry.
Okay.
Right. So like it's microscale atmospheric processes and how those processes impact sort of our air quality, particulate matter, and ozone.
Okay, so did you do this with UAH?
At UAH, yes.
Were you at the NSSTC?
I was, as a matter of fact, yeah. Yep.
National Space Science Technology
Center, correct.
Yeah, okay.
Yep. So got there in 2006, and the first year and a half or so was really trying to get spun up on organic chemistry, which was a weed out course at Mizzou for the doctoral program, right? For medical doctors, right?
So they're really serious. They'll do well if they're not.
Correct. So I avoided that like the plague. I got my two chemistry courses and got on out of there. So when I came here, I had to learn all of that. And in the process, I was sort of doing the theoretical development for an instrumentation for the EPA to monitor low concentration volatile organic compounds at the ground. So that was sponsored through the Jefferson County Department of Health down there in Birmingham, because they had some really bad air quality problems. And so I did all the math and showed that it would work. And then in the last couple of years towards my PhD, I developed a prototype, long nights, work over the weekends, that kind of thing. In the process, met my wife while we were in grad school. She was actually working hurricane research. She had flown in the Hurricane Hunters in the aircraft as part of some...
I bet it's a hoot at your house when there's bad weather.
Oh, yeah. Yeah, the kids are all under the stairs, and I'm got my face on the window. So anyway, built that instrument, took it over to Research Triangle Park for the EPA and said, here's your instrument. How many do you want? And they're like, we can't pay you. I was like, cool. Okay, so what do I do, right? I defended in October of 2011, and so I basically found out that I wasn't going to have a job right walking up to my defense. And then I had worked with one of my graduate advisors to work out a postdoc, kind of continue it at University of New Hampshire up in Manchester. And he came down for my defense, and we were at the Space and Rocket Center just kind of hanging out, kind of showing him around. And he's like, I've got bad news. I'm changing universities. I don't have a postdoc for you anymore. So there's job loss number 2 before I'd even step foot out of the door. So a friend of mine I was going to church with was like, what do you know about software? And so I took on a job at Georgia Tech Research Institute as a back-end software developer for an Army test tool. Yeah. And I knew a little bit about software development, but that was not what I wanted to do for my career.
And this is a short version. You have
this is a much longer version.
You have had a circuitous path to get
Yeah,
where you
so
are now.
kind of from atmospheric scientist to atmospheric chemist to software developer to systems engineer. So the systems engineer step took place in about 2015. I shifted from that program into one of the projects out at PEO Missiles and Space on the project office side as a systems engineer. And I had a mentor that I sat one cube over from. So every time he was having a conversation, I'd kind of peek my head up above the cubicle wall and just kind of soak it in, right? And that's where I really kind of learned the processes and the discipline and how to write good requirements and the model-based aspect of it. I started diving in headfirst to that in 2016, working some problem sets that I knew I could kind of work on the MBSE side. So it's really been on the job and mentorship, which is why those are two very important aspects to me as I've kind of embedded within NCOSE and things like that.
Okay, so two things. In NCOSE, you are the Huntsville Chapter of NCOSE president, and that NCOSE is the International Council on Systems Engineering. You are an affiliated professor at UAH still, but you are right now. Your job is that you are the chief architect for IBCS, the Integrated Battle Command System for Northrop Grumman.
Correct.
So, so I would say, wow, you're about the most, at least as educated as anybody I know.
I appreciate that. I appreciate that. And, more degrees than a thermometer.
Do you like to read?
To I mean, I do love to read. I think I ticked off 65 books last year. This year,
okay, you're hacking me off now.
Yeah, sorry.
It's
sorry.
Like, and once again, your house must be a hoot because it sounds like your wife's pretty educated too.
She's very smart. She's definitely the smarter of the two of us because she got her master's degree and started working. So then I just kept on going to school because I was a glutton for punishment.
Okay, so let's talk about model-based systems engineering, which you are about as invested as anybody in the history of mankind. Are you an evangelist for this?
Oh, absolutely.
I mean, when you talk to people, what do you say? I mean,
absolutely.
After you've told them your story,
right?
Long version, probably sometimes.
Yeah, fair.
There's not more partying in the long version, I would expect. But
right.
What do you say? What do you say when if somebody says, "Yeah, we've been talking about that at my company, but we don't know if we want to do that"? What
Correct.
Do you say?
Yeah. So I mean, systems engineering as a discipline is really sort of new in the grand scheme of engineering, right? So about 1960 is when it really started to formalize as a discipline, and NCOSE kind of followed up right behind that, and so. It's been a slow adoption from a systems engineering perspective. And then when you throw on top of it this whole model-based thing where it's really more about the tooling and how you do systems engineering, how you document it, and how you display that, right? That adoption has slowed even more, right? And to your point, to the question that you're kind of asking, like, well, my company is kind of thinking about it, but we're not so sure. I've got a lot of anecdotal stories to kind of point to, but there's a lot of research that shows that going model-based drastically improves your processes, drastically improves your ability to reuse things so that you can kind of fast track into new projects and things like that. But really I brought this up, we hosted an MBSE symposium here back in May, and I was on a panel there, and my comment there was, in 3 to 5 years, I think the model-based gets dropped off of model-based systems engineering. It's just systems engineering. It's how we do business.
Okay, so the model-based won't be.
I don't think so.
You say that they'll just quit saying it because it's just part of what you do.
Systems engineering, right? We don't say IDE-based software development.
Yeah.
It's just software development or software engineering. That's just, you put that model-based thing to kind of differentiate between sort of the way we used to do things, the way we do things now.
I want to ask you, how encumbered have you been by the way people used to do things? Were you doing systems engineering when it was
paper based?
Paper based.
Yeah. So I would say encumbered is probably a good way to put that, because there's sort of this idea where you have to take the old way of doing things and kind of morph the new way of doing things into the old way of doing things. That's how I kind of originally started, right? Because I was trying to get people to see that there's value in doing this. There's process improvements. I can auto-generate documents out of them if you want to see documents out of the models, those kinds of things. And so initially I was kind of trying to shoehorn the model-based aspect into sort of the traditional paper-based. That was almost 10 years ago. Now I'm just like, forget it. I'm going to do it the smart way, the model-based way, the way we do things now.
What was the thing that made you just say, not what you just said, just I'm going to do it that way. What was the thing that took you over the edge, where you thought, no, I'm not hanging on to that way we used to stuff. I'm going full bore.
I think the line of demarcation really came from when I started to see in requests for proposals, from different customers and stuff, a model-based requirement. Your engineering is done model-based. Once the acquisition side of the world kind of caught up that was the way we were doing business now, it's like, okay, take off the handcuffs and let's just do things smartly, right? We can still kind of follow the systems engineering V traditional, but we can do it in a model-based way. And there's still that evangelistic aspect of it, like you were talking about, of, where in the phase are you in the life cycle of the program? How does model-based help? So I definitely have some graphs and some charts and some views to kind of show how that all works. But that was really kind of the tipping point for me was, okay, the acquisition community has realized that we're not just doing things by paper anymore. And they were much slower to adopt it than sort of I'll call them the worker bees, the ones that are actually doing the real engineering.
Okay, another guy I've interviewed talked about the fact that you can't, and he is always trying to talk to people about model-based systems engineering also. He says, but you can't make people do that.
Correct.
You have to show them the light.
That's right.
Is that the way you do it? And if it is, how do you show them the light?
Yeah, so I would say in my previous role, when I was at I3 as a senior technologist, it was more showing people the light, taking a problem set, kind of building up some models from there, showing them what I could do, what the tools could do for them. We had an activity where we were actually writing a proposal that was very heavily model-based. Like the request for proposal was, hey, do all these things model-based. And so we wrote the entire proposal, work breakdown structure, the whole shoot and match in model-based systems engineering, generated everything out, and proved out to the customer, yay, verily, these guys actually know what they're talking about. So that was kind of a proof is in the pudding kind of aspect. Now my current role is, because of the kind of level of leadership that I'm at, this is the way we're going to do things. I don't have to prove to anybody that this is how we're going to do things. This is how we do business now.
Okay, so you're working on integrated battle command system. And part of that is finding out you have multiple customers and they all have similar needs, but I bet they all have some needs that aren't quite the same for the other groups.
That's true.
And so how could you even do that, considering the meetings you would have to have if you weren't doing it digitally? How you could do it, but I mean, because we've done amazing things. We went to the moon, and nobody even knew what a model.
Everything was analog on the shuttle.
But it would be so much harder to do it. I won't say old because that makes it sound like it's a long time ago, but a few years ago, wouldn't it?
Yeah, and so on IBCS, we use a scaled agile framework to kind of rack and stack and define the level of work that needs to be done within a program increment. That's kind of like the high level sort of agile construct that we're using. So what kind of happens, what leads into that sort of prioritization of the level of work that needs to get done is there's planning meetings that happen with the various stakeholders to kind of say like, hey, this unit needs this capability, or hey, this country is really looking for this, and we kind of rack and stack them, and then we kind of have, I'll say, healthy conversations behind what's priority and what's not. And then we sit down together for a couple of days and we go, okay, this is really priority. This is how long we think it's going to take. This is how much capacity it's going to take. This is the team. These are the teams that are going to be working on those problems. So in that sort of scaled agile framework that we've adopted, model-based systems engineering is all over that. We're still using different tools to kind of manage our tickets and our documentation, things like that. But on the back end, all of our engineering artifacts are all generated out of model-based systems engineering. All of our requirements are tracked in MBSE. And so sort of the engineering that happens after all the planning and the heated discussions and the long nights and those kinds of things, the engineering itself is being done in MBSE.
Okay, so all the people, and you're the chief architect, there are probably a lot of people working on this project with you, and I would assume a lot of them don't live here.
Most of them do live here. We do have we have teams here, there, and everywhere, but
okay, but I mean,
the majority are
here
here.
Probably, I would expect there's emails and Zoom calls more so than everybody getting together in a big room. Is everybody as in tune to what you're doing and the way you're doing it as you are?
No, and actually kind of came to that realization probably the other day. is that in order to get this laid flat, to get everybody kind of marching to the same beat, you've got to communicate, right? Part of being a technical leader is being able to communicate. It's not just having a vision, it's being able to communicate it at different levels, right? Like I can go down into the weeds with all the, kind of smart folks and kind of give it them one way. Yeah. But then when you go up to executive leadership or to...
Okay, well, this as an aside, executives aren't stupid. They're just not engineers.
Correct. Yeah. I don't mean to insinuate that.
No. We all say the same thing. And say, wait a minute, he's talking like we don't know. But you know what I mean? They're not as technically proficient.
Correct. So. Or they were at one time, and now they've been focusing so much on the programmatic side, which... that's some of that's Greek to me. So I'm glad that those guys are there. Those guys and gals are there.
We want you guys to watch us too. You guys and ladies.
Yeah, absolutely, absolutely. And so it's having the ability to take a vision, take a plan, and communicate it at all echelons. I'll say, and that's one of those things that it's kind of dawned on me that at the sort of lower levels, at the worker bee levels, I think that vision has been very clearly communicated. But up the chain, it's not as clear. And so that can cause some disconnects between conversations that they may be having up at their levels with stakeholders. And they're like, hey, yeah, we're working on this thing. Well, we haven't even actually started working on that thing. So you don't want to make them have to walk it back, that kind of thing. So
Chris, there's the learning curve, but does it ever come up that we're going to have to pay to train people?
Absolutely. That's constantly part of the conversation.
We're going to have to spend money, and if we do it the way we were doing it 5 years ago, we don't have to spend money. We already know how to do that.
Absolutely.
So how do you jump that hurdle?
Yeah, that's a great question. So within Northrop Grumman, we do have a series of training applications and tools and things like that people have access to as soon as you walk in the door. Part of the struggle there is making sure that they know that those tools exist. And oftentimes it's, on your own time, you can go and kind of take that training. That's available. But there's other avenues, right? Like DigitalWorks has their cloud environment that people can get access to and start doing training. I think they briefed last week at NCOSE Huntsville's chapter meeting that they're going to be standing up some training opportunities, which is super cool. There's other organizations like Studio SE or things like that have on-demand training, which I think would be very, very good. But kind of going back to sort of when I started all of this MBSE stuff back in 2015, mine was all on the job, right? I opened the tool and I dove in head first. I would not advise that for like larger teams.
Wait a minute,
because that would cause chaos.
You have 46 degrees. Of course you do.
Yeah. It's chaos if you have a team of this size to try to do that sort of thing. Yeah. So they've been trying to formalize that, but the real issue is turnover, right?
Yeah.
Here in Huntsville, the market is hot and people will find other opportunities and go. So you take the time to train up a person and they're there for 1, 2, 3 years and then they're off going to do something else. And I don't fault them for chasing after opportunities. That's completely within what they want to do depending on what their career goals are. But it becomes sort of a cost benefit thing for the organizations to determine how much training do you want to provide? How many resources do you want to dump into training a new hire and then find out that, within 6, 8, 9 months they're gone. You know what I mean?
Yeah.
So that's a real struggle.
But I would assume your counter argument when they hesitate is, you want us to be efficient,
right?
I mean, because efficiency, I would think, with every organization is huge.
That's a huge piece. It's the efficiency. It's the giving technical folks the cool stuff to work on so they want to stick around. There's a bit of a disconnect that I've found across my career that, what really drives somebody who's more like programmatically minded versus what drives somebody who's technically minded. I like solving hard problems. I don't like managing spreadsheets and attending meetings that don't necessarily, push the needle from a career perspective. So how do we challenge those technically minded people? And it's giving them those tools in their tool belt to continue to do that kind of work, right? You got to continue to challenge them and continue to push them and give them new opportunities to learn new things. This is coming from the, like you said, I think you said 46 degrees. Yeah. That might be a bit of an exaggeration.
Well, okay, you have 43. I'm sorry. Okay. I got it wrong.
Hopefully that makes sense.
Yeah, and the thing is, it's like you think that the folks dragging their feet are going to drag. This is probably a little too literal, but drag themselves right out of jobs.
It can be
if they don't in the next few years. When that's the sport,
right?
Do you talk about that?
Oh,
to
I
people?
absolutely do. So I've had a couple of, we'll call them instances with other colleagues that when it comes to MBSE and trying to get things in a model that can actually be executed to identify gaps and things like that, I run out of fingers and toes in the conversations that I've had with people who are like, well, that's not how we always do business, or that's not how we used to do things. And nothing will crush innovation and momentum like that's not how we used to do things. And so I've gotten to the point in my career where if I run into those, we'll call them barriers of that's not how we used to do things, then I don't have time for you. We're going to keep moving forward. We're going to keep pressing on. And if you want to continue to kind of do things the air quotes old way, then be my guest. But you either get on the bus or the bus is going to run you right over.
Is that resistance lessening? I mean,
It is.
Is it discernibly each day there are a few less companies, a few less people who are pushing back?
Yeah, it is. And a lot of it comes back to, the customers are asking for this. It's coming in through RFPs and things like that. I kind of equate it to, about 25, 30 years ago when we shifted from slide rules and graph paper to computer-aided design. Right, there was the folks that still walked around with their slide rules and their pencils and their pocket protectors that were kind of like, that's not how we used to do things. So I'm going to keep drawing.
Some slide rolls on the wall back there.
And I never had one of those. That was before my time.
Times have changed.
Yes, they have. But it was a slow adoption to now CAD is just the de facto how you do mechanical engineering, how you do complex fluid dynamics and those kind of things. MBSE is kind of on that precipice where you still have some folks that, want to continue to manage their spreadsheets and build charts in PowerPoint. And I think that we're at that tipping point where I think we're going to start to see more and more, or fewer and fewer of those hesitant folks that want to get on the bus.
And earlier you said 4 or 5 years before you don't even mention the model base. It's just that everybody understands.
It's just systems engineering. Yep. Yeah, it's coming. And I'm going to keep pressing until it becomes a reality. Because I've said it in a lot of forums, and now it's going to be on YouTube, so it's going to be out there in the ether for everybody to see. So.
Okay, and in COSI, I mean, you've got a national organization. I would bet it's international. It's an international.
Yeah.
So it's the kind of thing that everybody knows, but there's some folks who just don't want to, get in the water up to their necks because it's cold.
Yeah.
So what do you do?
That's a good question. So I have seen in the industry, there's been a lot more symposiums, conferences, things like that, just more communication. And in those meetings, as a technical person, I've always found it very intriguing that people are doing things that I would have never even thought of doing with the tools and with the capabilities that really start to get those creative juices flowing. So I think just continuing to tell the stories, talk about the success stories, be collaborative in how those things are shared, right? Model-based at its core is collaborative, and it's not, I'm going to hold on to this information, I'm going to save it on my local computer, and I'm never going to talk to anybody about it again, which really appeals to my academic side of, share information, let's get smarter about this together, and let's help it grow together. I think DigitalWorks is doing a great job of trying to continue that message, right? Let's be collaborative. Let's share information. Let's try to lay this flat. Calhoun's doing it. UAH is doing it just locally. Other universities across the country and around the world are being far more communicative about what they're doing. And I think that's going to do nothing but help.
Okay, so your life is nothing but learning and education. So
I hope so.
Doing this, so you haven't, would you say, I think you would say, I have not arrived, Steve. I'm still learning stuff every day. And
Absolutely.
You kind of just said that when you said
Absolutely.
How people are using the tools.
Mm-hmm. Yeah, absolutely. Lifelong learner. That's always been my MO. Even when I was a kid, I was the one that was taking apart the class pencil sharpener to figure out how it worked. I've always been that way. And no pride in ownership, right? Like if you learn something, go tell somebody, right? Go tell somebody and they'll tell somebody. And then those ideas will start to flow, and it just blows up from there. I'm also part of the object management group that started defining the specs and the standards for these tools, for SysML and things like that. And just the group of folks that are doing that, I mean, they've forgotten more about systems engineering than I'll ever know. And I just soak it in. I'm like a sponge. I just love it.
Well, and isn't that, it's my observation. I'm not an engineer, but engineers like to figure things out.
Yes.
Don't you?
Oh yeah, absolutely. How's it work? Where did it come from? What's its origin? Why was it there in the first place? Yeah, those are the questions. If you ask my parents if they were here, they would say they're still alive. I don't mean if they were here in the studio is basically what I'm saying. They would say like he was the kid that was asking the 1,001 questions about, you know, why is it this way, Daddy, and why does it work this way, Mom, and those kinds of things. Like I've been that way ever since I could talk.
And you found answers with model-based systems engineering.
I'm finding those answers, and I'm continuing to find answers. I learn something new every day inside the tools, or even with the way that the standard is laid out, how it all integrates together. I'm learning every day, and I'm having a blast.
Okay, Dr. B, I'm going to ask this because I'm a big reader. A couple of books that you really liked. You said you ticked off 65
last year. So my reading last year was really kind of focused in on like World War II kind of time
that's
frame.
Cool. That's how I get it. I'm there myself.
Yep. So there's a book called The General and the Genius that's about the atomic bomb program.
General Groves and Oppenheimer.
Oppenheimer. Yeah, it's fascinating.
Yeah.
You know, just kind of the interplay. There's a book called Skunk Works that kind of spans that time frame, right? But it's all about how Lockheed Martin kind of built all their stealth programs and the environment those were all built in, right? It's engineering at the core, but it's kind of how people are wired, and just fascinating stuff to me.
Any fiction?
I'm not a huge fiction guy. There's a fiction book that my wife actually got me to read, which was also World War II era, so it kind of fit in the theme for last year. It was what's called All the Light You Cannot See.
Oh yeah,
right.
Anthony Doerr.
Anthony Doerr. Yeah. Yep. Fascinating book. I thought it kind of shed some light on some of the activities that were ongoing. But yeah, I'm not a huge fiction guy.
Well,
I tend to lean more toward historical.
You're sounds like most of your reading is about how people got around all the technical challenges. Back then, yeah, and how it all kind of intertwines together. When I was a kid, there's a British guy, James Burke. I don't know if you're familiar with him, but he wrote a book called Circles and The Knowledge Web. They're two separate books, and it's incredibly fascinating. He'll pick a topic and he'll start kind of with its origin and wrap it all the way in through all of human history, and then it ultimately rolls back into the original topic. It's fascinating. He had a BBC show. Say that one again. Say that because I think somebody's going to say, I want to check that out.
James Burke, Knowledge Web, and Circles. Okay. And I think he had one more that the name is escaping me. But he was a BBC guy. He had a TV show that was like syndicated and all that stuff over in the UK. Fascinating stuff. All right. So yeah, definitely check that out.
Everything you do sounds like it might be fascinating.
I hope so. I try to keep it interesting.
All right, man. Appreciate you being here, Dr. Patrick Buckley.
Yep.
Thank you.
Thank you, Steve.
And thank you for joining us. And we will be back, of course. And don't forget, it works.